All right, this is section, or excuse me, part 2 of Unit 3A, looking at percentages and uses of percentage. So this part we're going to be looking at a concept of absolute and relative change. So the absolute change just describes the actual increase or decrease from a reference value to a new value. So from kind of a starting point to an ending point. So this will be, again, the actual increase or decrease. So this could be a positive or a negative on this one. So here's kind of the little formula. Absolute equals the new value minus the reference value. And again, reference is just kind of where we started. Now the relative change, when you see relative, that word usually incites a percentage. So the relative change is the size of the absolute change in comparison to the reference value. So the size of the change in comparison to where we started is another way to think of it, and can be expressed as taking the difference, so the absolute change, new value minus reference value, and dividing that by the reference value, and then times it by 100 to get us a percentage. Okay, so those are a couple of formulas that will be helpful for you. So I'm going to highlight those in a different color for you. So here's your absolute change, and then this guy right here is your relative change. So let's look at a couple of these. So we want to find the absolute change and the relative change in the following cases. So we have the average student loan debt after a bachelor's degree increased from $18,550 to $28,500. So again, what we're doing here is first find the absolute change. So take the new value minus the reference value. So this is the new value, and this is the reference. You could also think of it as the old value or the starting point. So the absolute change is just going to be the new, which is 28,500 minus 18,550, and that's going to tell us relatively how much it changed. So it changed by 10,400 when I subtract those. So that's how much the average student loan debt for a bachelor's degree increased over that 10-year span. Okay, now to find the relative change on this one. So we're going to take, and again, it is the absolute change, but in the formula, it's the new minus the reference. So that, notice it's your absolute change divided by your reference, which is where we started out at, what we're referring back to. So 18,550. And first off, I'm just going to do this calculation here so you can see that as a decimal you get 0.561. Okay, and then we're going to take that, change it to a percent, so you times it by 100 or move that decimal over. So it's 56.1% is the relative change. So we had an increase, so since both of these are positive, we know that they are increases. Okay, another one. Let's look at the U.S. per capita consumption of beef. It decreased from 67.8 pounds in 2000 to 55.4 pounds in 2008. So when it says decreased from, so here's where we started. So this 68 is our reference. And then 55.4 is going to be the new value that we have. So what we're going to do is first find, again, the absolute change. So I'm just going to write ABS. Change is the 55.4 minus 67.8. So in this case, we're going to have a negative 12.4 because it decreased. So that negative is there to show a decrease. And then for the relative change, again, I'm just going to write negative 12.4, but again, that's the absolute change over our reference value. which is the 67.8. So this is going to be negative, and again I'm just going to write out our decimal here, so negative 0.183, which is 18.3%. So that's looking at, again, absolute change. So absolute change tells us how much it changed, and then relative change lets us know how much it changed relative to where we began, or the reference point. Okay. In this next one, we are going to again find or describe this here in two ways, as an absolute change and then a relative change. And so we're going to look at alcohol use by high school seniors decreased from 50% in 2000 to 35.3% in 2015. And so again, we're decreasing, so we're going to see a negative there. And so as we look at this, we take the new, which was 35.3, minus the old, which was 50. So this is the absolute change. Sorry, I didn't write out absolute change. So absolute change equals 35.3 minus 50, which is a negative 14.7. So we have negative 14.7 is our absolute change. Then our relative change is going to be equal to, again, 35.3 minus 50, all of that divided by our reference point, which was 50, and this turns out to be 29.4%. Okay, so negative 29.4%, because we decreased. So we can see, again, absolute, how much did it change, and then relative, how much is, when we compare 50% and 35%, that's a 29% decrease over time. So that's what absolute and relative change do for us. So let me check my time here, see how we're doing. We're doing okay. We can go a little bit further. Okay, so next we're going to be looking at kind of this idea of versus more than or less than. So when we're comparing something, if a new or a compared value is, we call it P% more than the reference value or the starting value, it is, and this is kind of a way to think of it, 100 plus P% of the reference value. Okay, if it's less, we do 100 minus P%. So let's do an example here and get an idea of what we mean by this more or less than. So in 53, we have the population of Michigan is 63% greater than the population of Missouri. So Michigan's population is blank percent of Missouri's population. So since it's greater than, it's going to be an increase, or more than. So what we say is Michigan's population. So we start with 100% of Michigan's population. You always start with 100, and then if we're growing, we add on what percentage we're growing by. So 100, and it's more than 63, or excuse me, 63% greater than. So we add 63, and so we would say that Michigan's population is 163% of Missouri's population. Where this is going to come in handy is when we have to do some calculations and have to compare the two. We're going to take the 163% and change that, so I should say percent here, to a decimal 1.63, and then when you have to do calculations with comparing Michigan and Missouri, we're going to be using the number 1.63. So we go from a percent down to a decimal. So the next one is the net worth of Warren Buffett is 18.9% less than the net worth of Bill Gates. So Warren Buffett's net worth is blank percent of Bill Gates' net worth. So in this case, again, you always start at 100%. Since Warren Buffett is 18.9% less, we are going to subtract 18.9. And again, this is a percent, so I'll keep that out there. And so when I take 100 minus 18.9, and that's going to be percent, it's 81.1%. So Warren Buffett's net worth is 81.1% of Bill Gates' net worth. And if our percent is less than 1, then that means the number's in the end going to be less. If it's greater than 1, it's going to be more. And again, in a calculation, we'd be using the decimal value of 0.811. So in the next video, we'll look at some of these problems as far as how we could use this idea to find and solve percentage problems in a real-world setting.